Hello everyone. In this video tutorial, we'll learn about the Java synchronization. So what is this? What is this called as the Java synchronization? The thing is very clear. The synchronization, the term comes with the Java threads. First point. The second point is that why to use synchronization, and the answer is when multiple threads are running in your system and you want that only a particular thread to access a shared resource. For example, suppose the shared resource is a bank amount, the amount which is there in your bank account, and suppose that more than one accounts are there, it's a joint account. So you have to make sure that only one account holder at a time can access the bank's amount. Otherwise, multiple depositors will go and multiple, the account holders will go, and either they may take the money all together. Then you cannot keep the track of where the money has gone and who has taken the money, correct? So when there is a shared resource, you should make sure that only a single person should go and access that particular amount. That is the synchronization concept in Java. It's the capability, it's the capacity, to control the access of multiple threads to any shared resource. So we'll definitely access the shared resource, but make sure that the shared resource is accessed by a single thread at a time. That is what ensured by the Java synchronization. Yes, it allows only one thread to access the shared resource. So why to use the synchronization? I told just before, to prevent the thread interference and to prevent the problem of inconsistency. Suppose there is a ticket booking system. I'm giving another example. Suppose there is a ticket booking system and there are 100 tickets left. Now, if you don't allow the synchronization, that is, if you don't implement the synchronization concept, then this 100 tickets may be accessed by 1000 people. And when the ticket will come down to the single ticket remaining, and still suppose 900 people are trying to book the ticket. If you don't make the synchronization, that is, if you consider each ticket booking agent as a single instance, as a single thread instance, and that ticket is a shared resource, so you have to make sure that only one agent acting as a thread in Java should get the access to the thread at a single time. Otherwise, two people will book the same ticket and it will be a big mess. Correct? So this is the consistency problem, and it can be removed by thread synchronization, because thread synchronization will prevent the wrong interference among the multiple threads. So what are the type of the synchronizations we have? We have the process synchronization and thread synchronization, but we are focusing right now in the thread synchronization. The process synchronization is out of our scope. It is dealt by the operating system generally. So we'll discuss only about the thread synchronization. So what is the thread synchronization? A thread synchronization is two types of thread synchronization available. One is the mutual exclusive one, another is the inter-thread communication. So inter-thread communication is also known as the cooperation, and that's a separate concept we'll explain later. Right now we are focusing on what? This synchronized method, synchronized block, and synchronized static blocks. So these concepts we are going to learn now. Yes, I think that the entire picture is clear in front of you, and this PDF which is shown in front of you, will get it in the description of this video. So you don't need to worry that all the things we are learning, and you no need to create a note right now. No need to write down anything. Just listen carefully to this video, and the programs I'll give, the programs will be executed in front of you. It will be explained line by line, so it will make you 100% clear to understand regarding the thread synchronization. So we'll learn about the mutual exclusive now. We'll learn about the synchronized method, synchronized block, and static synchronization. So what is mutual exclusiveness? It keeps the threads from interfering with one another while sharing data. That's what we are discussing, right? The interference. It will be removed. It will make the interference of multiple threads at a single time to a shared resource prevention. That will be the job over here. It can be achieved by what? By a synchronization method, by a synchronization block, and the static synchronization. These three are the concepts. We'll explain one by one. So before we go to explanation of all these concepts with the real world Java program, we'll first go through the concept of lock. Yes, what is a lock? Lock is nothing but it's a monitor which monitors that one shared object, one shared resource is accessed by one thread. So whenever one thread is accessing a particular shared resource, a lock will be applied to that thread and object, in between the thread and that object, so that the other thread cannot access that object unless the thread exit and the lock is removed. Then when the lock is removed, another thread will enter inside, then again another lock will be implemented. In this way the lock will work. Yes, Java 5 onwards the locking mechanism has been modified using what? Java util.concurrent locks. Yes, so different locks we have from there in Java 5 onwards. So we learned about the synchronization. Now we'll see that how synchronization helps in doing the data access through a particular multiple threads. I'll show this example first. I'll execute this program in front of you and then show you the output, and then we'll modify it with the thread synchronization, and then you can understand what's the synchronization benefit we have. So I've right clicked over there. I'm creating a new class. Yes, the new class name should be as the main method taking, correct na? So we'll write down this particular name of the thread. It will save the time. If I start writing this classes, it will take lots of time, right? So it's a method of saving the time and making the video length as small as possible while explaining all the concept in detail. So this is the class we have. Yes, so see that we have a particular class. The name of the class is table. It has a printable method. The name of the method is printable. It takes one integer argument. Now based on this integer argument, it iterates from I to phi, correct? From I is equals to 1 to 5 it iterates and it increments by 1, and this value of n is multiplied by the value of I each time, and it is printed. Yes, so if the value of n is equals to 10, then first it will print 10 into 1 is equals to 10. Next iteration it will print 10 into 2 is equals to 20, and till 10 into 5 is equals to 50, correct? And we are, after printing each value within the same iteration, we are calling the sleep method. Sleep method will make the thread paused, correct, for 400 millisecond. Yes, and if exception generates, then we'll print this particular exception. Now this print table will be called by multiple threads, and I'll show that if the threads, so this print table actually you have designed as a shared resource. This printable method and its execution is like a shared resource, and we have multiple threads, then we should supposed to have multiple threads. So we have these multiple threads. So what are the multiple threads we have? What are the multiple threads we have? We have class mythread1, then we have class mythread2. So these two threads we are creating. We are creating the thread, that's why you are extending the thread class, correct? Now one table class object reference is created given the name T. This is a table class object reference, correct? And here we have mythread1 constructor which takes this table T as a reference, and this particular value is, this particular past value of the table object is assigned to this particular object. So this object is created, correct? Table object will assign and created over here through the constructor of mythread1. Now the run method is defined, so that if you call the run method, the thread will start executing, correct? And this run method, that is when the thread will be in the runnable state and it will keep on running, that time it is calling by using the thread object, table object, that is the thread object, and it will call printable method with the value phi. So in the first iteration it will be phi, next iteration it will be phi into 2, and next iteration it will be phi into 3, and so on. The same thing is implemented for class mythread2, but here the difference is that in the running method, in the run method, where the thread will run, whenever the thread will start, it will come to the run method, right, automatically, and then this 100 is passed here. So if the thread 2 is running, then what will be having here? It will run 100 into 1, so 100, next 100 into 2 is equals to 200, and so on, correct? Now here we have the table obj is equals to new table. So the table object is created. Now this table object should be passed in the mythread1 and mythread2. That's how we have designed that. We have a single parameterized constructor. So T1 and T2 are the threads of the type what? Obj, correct? Which is the type of table. So definitely it will call the run method which is defined inside the body of the my thread 1 and my thread 2 for T1 and T2 respectively. Correct? Now we are starting the thread T1 over here in line number 34 and we are starting the thread T2 in line number 35 by calling the start method. Now this 34, line number 34 will definitely call the run method after it starts. Which run method it will call? My thread 1 run method. So it will call the printable method here in turn with the value 5. And this line number 35 will go and call this run method definitely and with the value of 100. Now the question is this shared, now we have two threads T1 and T2. These are the two threads running and both the threads are running and trying to execute this shared resource. The shared resource is printable method and whatever they are inside the method, that's the shared resource. Correct? Now if you run this particular program, what you'll see, it will run haphazardly. That is, there is no lock. That is, thread 1 is running, then immediately thread 2 is running, then thread 2 is running. See this? This is the thread 1 execution. Correct? It is giving the value 5. It is running with the value 5 into 1, then 5 into 2, then 5 into 3, then 5 into 4, then 5 into 5, because we are sleeping over here, na? We are forcing, you are sleeping. So definitely whenever one thread is sleeping, another thread will awaken. Correct? So thread 1 started here with the value 5, then thread 2 started with the value 100. See? We are passing the value 100, right? So it is printing over here 100. At the first it is printing 100. Then it is slept, but at that time T1 has not run. It will be running haphazardly. So if you run again and again, you may get different results. And as big the for loop is and as different the values are, the different results will be most probably different. I mean, the different execution will provide you different results most probably. So we are seeing that two threads are running not in order. There is no synchronization. So the shared resource is actually run and accessed by two threads haphazardly. We don't want that. We want that first one thread to get access to the shared resource, completes its execution, then the next method then the next thread will go and execute the shared resource, get the lock to the shared resource, and then execute the parts of the shared resource. So for that, what we'll do? That answer is also provided in this PDF. See this? We have, as a solution, we have just provided a single keyword into the method because the method is the shared resource, right? So which particular syntax we have used? This tiny synchronization method we have used. This particular keyword we have used. That makes all the difference here. See this? We have made this synchronized. That's it. Nothing else. Nothing else. Just the synchronized keyword we have added before the method. And if we run it again, see this, the result is completely different. 5, 10, 15, 20, 25, 100, 200, 300, 400, 400. So you can understand that these are the execution of thread 1. Even if there is sleep, but T2 can't start. T1 will sleep. Okay, after sleep of 400 milliseconds, it will again wake up and then again it will execute the next one. Even if you sleep for 1 second, 1 second is 1000 milliseconds, right? So it will be executing after 1 second, 5, after 1 second, 10, after 1 second, 15. So you understood that T1 got the lock of the shared resource void printable. This is a shared resource, right? Void printable. Yes. So this particular thread object is getting access to printable. So it will be get the lock and it will complete its execution. Then only the other thread will be able to understand. So now you imagine that these two threads are two ticket agents and this particular void printable as a tickets available. So you can understand it very clearly that one particular user, when it's getting the lock, should get the tickets first, then the other will get the tickets. Otherwise the same tickets, the front or rear or window side or upper or side lower, whatever the different type of the tickets are there, may be given to two different users. That should not be there. First the ticket should be assigned to one user, then the remaining ticket should be given to the another users. So in this way the synchronization is achieved in Java using the synchronized thread here. So we have given the first example in this particular example, that is the synchronizable threads. Now we have another way we'll see by using anonymous class. So anonymous class, we are using the same thing, okay? Here also you're using synchronized method only, but one example I'll give with the anonymous class, that how it can be happening with the anonymous class, and it's very easy. As you have understood the last program, this program will be definitely understanding. Okay, I don't think it is required to be executable, just I'll show over here. Yes. The name is 1, right? I think 1 will work. Yes. You can see that you have created the class table. The name of the class is table. Now here we have done the same thing exactly like the last program. But we have made some differences, some changes over here. What? We are not creating the threads and its classes. We are creating it on the flow. See this? This is the one anonymous class, and this is another anonymous class. There is no name of the class. The same lines of codes are there as you have seen in the last program, but here the entire thing has been put inside a anonymous class. So this is a anonymous class block which creates the thread 1 and then calling the run method with the which will in turn will call the printable method with the value 5, and there is a second anonymous class which is creating another thread T2 and running the next method printable with the value 100, and then we are starting this too. So exactly same behavior we are expecting. See this, it is synchronized. Okay, this resource is synchronized. So you are getting the benefit of synchronization over here. 5, 10, 15, 20, you are getting like this. Yes. So if you change that a millisecond to 1000, then it will delay for 1 second each. Again, the same response, same thing will be coming in front of you. So the same thing we have explained over here through the anonymous class example. That's it. No other difference. Finish. Yes. Now we see that synchronized block. So what we have seen in the last program is that the entire method is synchronized. We don't want sometimes the entire method to be synchronized. Rather, we want a particular segment of the code which recites to some particular method to be synchronized only. Suppose the method has many other things to do. Okay, it is doing lot of other things, but it is having the shared resource in line number 5 to line number 10. So why to make line number 1 to 4 and line number 11 to or line number 20 inside the synchronized block? So we don't want the synchronized method over here. The entire method will not synchronize. What will synchronize? Will synchronize the particular block of code which is getting shared by multiple threads. So suppose we have 500 lines of code in our method, but we want to synchronize only 5 lines. In such case, we want what? We want a synchronized block. Yes, it's very simple. Synchronized blocks are very simple. It's simpler than the if-else statement actually. See this, in case of if statement, we give the keyword, right? So here also you are giving the keyword synchronized. Then within the bracket, we have to provide the object reference, that which particular object will be passed, and then this particular things will be executed. So if you don't want to pass any particular object, just pass within the bracket this. This will refer to the current object, right? And most of the time that will be sufficient for you. Just to provide this within the bracket of the synchronized block, and that will do your job, because this will refer to the current object. In this particular example also we have done the same thing. We have used this here. Will refract it. Okay, the name of the class should be same as the name of the class which has the public static void main, correct? So we have to just change the name to show you by execution. Now the errors will go out. Yes. Well, so you can see that the same thing is there here. See that public class, class table is there. Then we have the void printable. Okay, but the entire here there might be lots of line of the code, correct? There might be code here. Then we have the code over here. There are lots of the code which we don't require to be synchronized. Which part we want to synchronize? Just this part. Just we need this part to be synchronized. That's why we are just making it inside the synchronized block. As simple as that. Yes. So this is the synchronized blocks example. This is the example of the synchronized block. See how synchronized block works. Synchronized keyword, and then we have the passing the argument this. So the current object, whatever the object, thread 1, thread 2, thread 3, thread 4, whatever the number of threads are there, whenever it will get inside the printable method, it will be referred as this. Now we are doing the same thing. We are having the same loops, and we are sleeping with the 400 millisecond. If it generates exception, then we are printing the exception over here. Correct, na? And then we are creating again the same my thread 1 in the same things. See this? Same constructor and same run method. Here also same my thread 2 class and same things. Same constructor, same run method. And here also you are creating the object. Each and everything is same. So then from the program, first program and this program, what is the difference? Last program we provided synchronized over here, and here you are providing the synchronization in a block. That's it. So same output. Because now this part is only shared. See, now thread 2 has executed. It's possible that thread 1 will execute first or thread 2 will execute first. So here in this example, thread 2 is executed first. There is no order that thread 1 will execute first or thread 2. No one can guarantee that. So we have executed thread 1, thread 2 first over here, and then thread 1. So this is the example of synchronized block. So these codes, these lines of code, whatever the code if you write over here, that will not be synchronized. Only this part will be synchronized. So the shared resource should be provided inside the synchronized block to make your program successful. So the same program you can use like the way we created the anonymous class in the last program and executed. The same thing can be possible over here. So I'll not waste your time and execute with the anonymous class, and simply it will be of no use. It's already you have learned it. Now we'll go to the next topic. The next way of synchronization we'll see. What's there is the static synchronization. Yes. So if you make any static method as synchronized, the lock will be on the class level, okay, not on the object level. So that's the very important thing. In the last time what you have seen, thread 1 is getting the lock, correct? Thread 2 is getting the lock. To whom? Getting to the method, synchronized method, or the block, synchronized block. But if you put the static method as synchronized, then lock will be on the class, because static methods are the class level variables, right? I mean the class level things, right? So it will get the lock into the class level only. So all the objects of the class will get the lock automatically. Yes. Without static synchronization, what happens? See this, there are 4 threads, suppose T1, T2, T3 and T4. So these 4 threads are running, and T1, T2 access the lock on object 1, T3, T4 have the locks access on the synchronized object 2, correct? Now the problem is that T1 and T2 will not access with haphazardly to object 1, but T1 or T2 can access object 2. There is a possibility. Yes, so you have to read these lines. There are 2 objects of shared class. Suppose table name object 1 and object 2. In case of synchronized method and synchronized block, there cannot be interference between T1 and T2 or T2, T3 and T4. There cannot be any interference because you have synchronized, na? But there can be, wait a minute, I'll highlight it. But there can be interference between T1 and T3 or T2 and T4, because T1 acquires another lock and T3 acquires another lock. It's possible. We don't want the interference between T1 and T3, right? We neither want to make the interference between T2 or T4. The solution is that synchronized block. What kind of synchronization block? Static synchronization. That's the only solution. This point is very important. The keyword synchronization means that only one thread can access the method at a time. And static synchronization means the only one thread can access the class at one time. The entire class level synchronization if you want to put, then you put into the static. Yes, now we'll see the code. This code we'll see, and this will be your last example. I don't want to take more time. I just wanted to make the video within 30 minutes so that you can get the entire concept clear regarding the synchronization within this amount of time. Okay. Thread synchronization, test synchronization. I'll make the refractor and try to make it fast. Half an hour target, half an hour. Yes. So we'll see here. See this now. What you have done over here, everything is same. See this? Yes. Yes, everything is almost same. Just we have not defined the constructor over here because we don't need a constructor. See this? See this? Just run we have put because we have created the threads directly. Yes, all the threads, all the my thread 1, my thread 2, my thread 3 and my thread 4. All 4 are the classes, right? And all 4 classes extended thread. So automatically if you create an object of these classes, you will get the threads, not T1, T2, T3 and T4. All of the threads now. If you call the start method, then from the new state, it will go to the runnable state, correct? And then T1.start will in turn call T1.run. So this run method will be called automatically by T1. This will be called automatically by the T2. This will be called automatically by the T3, and this will be called automatically by the T4. Okay, so those things you know already, right? And we are seeing a new thing that you are passing the different values. For T1 it is passing 1, T2 passing 10 in the method printable, I'm telling. Okay, T3 is passing 100 and T4 is passing 1000. So whenever you are passing these values, definitely this line will get this value 1 to 1 or 10 or 100 or 1000, and this value will be printed over here, n into I. Yes, 1 into 1, then 10 into 1, 100 into 1, 1000 into 1, and so on these things. Correct? Now, static, synchronized, static, void, printable. Here, we are seeing just a new keyword we have added over here. What's that? Static. That's it. That's it. Otherwise, the flow of the program is same like the flow of the last all three programs examples which are shown in front of you just before. Everything is same, right? Just this one single keyword is different. What's that? Static. So how this thing makes the difference at all? How this can make something new in your life of the synchronization, the life of synchronization, how it changes. We'll see that. If you execute that, you can see how it now executes differently. See, only one thread will execute at a time. If it one, then 1, 2, 3, 4, 5. Okay, till what we are going? Till 10 we are going. Okay, so till 10. Then 1000 started. So thread 4 started. Now thread 2 started. 10, 20, 30 till 100. Yes? Yes, now 100, 200, 300. So thread 3 started now and it's finished. So if you put more milliseconds, you can get better understanding. See, T1 starts. When you can understand that T1 starts? When T1 starts, it will come with the multiplication of value of 1. When T2 will start, it will come with the multiplication of the value 10. When it will T3, it will come with the multiplication of 100. When T4 starts, it will come and runs. It will start with the value of thousands. Correct? See here, because we are multiplying with the values, so it will multiple till 10. Correct? Now I have given the slave time 1000, so it will be more clear you to understand. 1, 2. So thread 1 started now. Thread 1 running this block, this synchronized static block. So in the class level, a single thread can start. Now which one started? Thread 2 started. Thread 2 is running. Yes. Now thread. Yes. Yes. One thread has gone. See here now one thread has gone into the level now. Now 100 started, means the third thread started. The fourth one started, I think, with 100 value, na? Yes, 1000. 100 means, yeah. So fourth one started here. Here, fourth one started. Yes. Yes, 10 to 100 means there it was running which thread? Here it was running the second thread. Correct? Then at the top, we are running with the which thread? 100. 100 means thread 3 was running. Then we have 1 to 10 means thread 1 was running. Thread 1 was running. So in this way, we can see that how static keyword basically helps you in getting that thread level synchronization. Yes, so this is all about the synchronization. I have planned to complete this video within 30 minutes, and I'll give this particular PDF in the description of the video, so that you can just download this particular PDF, run this program in your computer, in your own hand, see the differences, remove some keywords and see the differences, add some keywords and see the differences. So if you like this video, like the way I'm teaching you, then please subscribe to my channel. Thank you very much.